Hey everyone, welcome back on my channel. I'm very happy now to start again this series of tutorial, and today I'm going to show you guys how to use Python for your simulation. Python is a very important tool, especially if you work in Abaqus, because allow you to do a lot of things, including parametric analysis or turning in a completely automatic system your analysis environment. And this is very helpful, especially when you work on always on similar geometries, or you have to do a lot of tedious tasks, and that using Python would allow you to do things much faster than clicking on all these buttons. So first of all, as always, we start by imposing our working directory, something that is good for you. In this case, I have a working directory for this tutorial video, and then we can start straight away. Today I will show you a simple example, and then we will go over the code. So let's get started. The first advice that I give you in order to learn Python and how to use Python in Abaqus is to use the macro manager. What the macro manager does is essentially recording all the command that you input through the GUI in a file, and this will correspond to Python code. So now we can click create, we save in the work directory, and then we can start. So now you can see that he starts to record, so whatever I do here will be recorded in a file. So first of all, I create my part, create a beam. This will be a 3D deformable object. And then we just go for a very simple squared cross section. So we draw our rectangle, and then I start to add dimension. Why I'm doing this? Because as I say to you, every command that we imposed will be recorded in some way. So for example, if we work mainly on beams, we may have a series of parameters that we may decide to change along the way. So if you click on each command, this will correspond to a command in Python that we can later on manage to modify in order to do whatever we want. So in this case, we just want to add these two things, and then it's done, and then we extrude for a certain length. For example, 200 millimeters. I'm working millimeter. And we create material. For example, a common steel would be fine, and we give just elastic properties. So Young modulus and Poisson ratio. Because I'm working in millimeter, this needs to be times 10,000. So now the material is created. We can create a very simple section, beam section, homogeneous. I'm going very fast here because I believe that you have some basic knowledge of Abaqus. But if you have any question and you would like to see me doing a video on a particular topic, please leave something, a comment down below, and I will try to figure out for you. So going forward, we have steel, it's not doing stress constraint, so it's fine. Then we can just assign these. We create a set, we click on the beam, and then we click this set for us. And now we can see that everything is being selected properly, and the beam is green, so it's fine. We can go mesh, we set up a very rough mesh just to be sure that we can deal with that, and then we mesh. So you can see very rough mesh for now. So everything here is done. We can go in the assembly. In the assembly, the first thing that we want to do is importing a part, and then start to create some set. So for example, we can create a set DC. So remember, this simple command that, of course, now the video looks boring, but anything that I'm doing now is recording also this movement, which of course in an analysis perspective is completely useless, and we are going to remove this. Okay, we are now creating a pressure surface surface set on the top, just to be then sure that we can apply directly on that surface our load. And then we create a step. Now this step will be a static general. And what I'm going to do is playing a bit with this number. Now I'm doing this only for a specific reason. Because every time you click on something that is not standard, he will essentially save this option, and then we can turn off, turn on, and modify whatever we want. Oops. Okay. So then we can just go in and define the load. So the load will be a simple pressure, and this will be applied on the top. This is 200, for example, and then the boundary condition will be an encaster. Select this side, so you can see that is highlighted, so I'm sure about what I'm going to take. Okay, and then I go for a full encaster. Then the model is nearly done. What I'm going to do, I'm going to create a job and run it. So now this will be pretty straightforward, and I can also, once it's submitted, I can also stop to record, because at this moment everything that I was needed to run the job is completely recorded, so I don't need any more. Some error happened. Oh yeah, that's probably because we set up some weird option, but this was only a matter of showing you what's happened next. So now don't forget about the analysis aborted. This is silly things, because what is important now, if you go in your working directory, you will find a true file like that, and this is something that I've done previously. Now we go for this. Right click and open with the Notepad++ with the is very good for doing these things, also because you have a plenty choice of languages. In this case you need Python, because this is code in Python. So this is how it looks like, what we have done in the last 10 minutes. So essentially the Python code that you see here, you can remove this, is divided into two parts. The first part is and then we can remove these, and all these need to be removed, the indentation, because Python, remember, is very sensible to indentation, so be respectful about that. So now you can see that we have a block here of import command, and these are very important, because essentially despite you may be expert in Python, doesn't mean that you can script Python for Abaqus. And this is because Abaqus, of course, uses Python, but the way on how it uses and all the built-in function and the use of the vector and tuples is very strict to how Abaqus wants this to be done. So you have a bit to force yourself to do things that may not look correct, because Abaqus likes them in that way. So the best way to figure out how to use Python for Abaqus is just looking at this command. So now you can see that this is the entire code, and we have even the submit. Now I'm going to do a comment in here, and I save this, and I will just do this. And then by going in the run script, then you have the entire job already done. So you can see that essentially the mesh is there, the load is there. So you can see the potential. The potential is that once you have done one model, if you spend and you invest some more time, as we are going to do, in order to improve the model and make it parametric, you will be able to have essentially a script that can simulate any beam, for example, that you need. And more you work on this, more flexibility you can have. So now the code here is a bit messy, because essentially everything is packed. There is no way to distinguish the things. So I'm going to go across this code and then we will switch to the code that I scripted for you based on exactly this same example. But I want to show you some particularities first. So you can see that first of all, there are some ways to divide things. So looks for different keywords. For example, this part, hence here, what it does is creating the sketch area. You can see it from the fact that he accessed to the model and then constraint sketch. Then he gave a profile name to the drawings that you are going to use to produce, and then you have a sheet size of 200. So for example, this value can be changed as we wish, or we can make it parametric. But this is not very important, and honestly, it just needed for essentially creating the geometry that we need. Then you can see that he created this vector that is required to access to the geometry, to the vertices, etc., etc., etc. And here he based on S, which is defined here as this. He created his primary object as a standalone, and then first part, creating the rectangle. You can see S, which is this function, then rectangle, and then he expects 2 points with their respective coordinate. So here you can see that he will do a rectangle and will put a point in -5, 5, and 5, -5. Now, the second part is here, and this is why it was important to do the quotation of the drawing, because you can see here that essentially he picked the 2 vertices that we need and apply at certain distance a constraint. So this is just for the display. So essentially position the constraint in terms of visualization. But this is the actual value, and this is the actual value for the other one. And then what you can do, you can create a variable beam h equal to 10 and beam w equal to 25. And then what you can do is just remove these here and remove these here. And what you will see is that if I now save this and run again the Python script, you have a completely different geometry, and you can also see that the mesh will be the same, but of course on a smaller domain. So this should show you the power of using Python, because anything can then get parameterized. Then you can go forward, and here you can see that he created the part, in this case the model, and then there is the extrusion. So we can okay, so this is the extrusion, so how much you extrude, and then we can put beam underscore health, so the extrusion, and then we can put 400 instead of 200. And then we can put this here. Oops. Save, and then try to redo again. I always suggest at the beginning to do this step in order to be sure that you don't produce mistakes. And this is very important, because otherwise then you end up in having issues. And then you don't know where exactly they are. So now we change these, these, and these, and already the geometry essentially is changed. Then here you can see that we have at this point there are some areas. So this part, I think, this part, yes. So every time you have a p equal something equal mbd, this is creating a variable to which corresponds to a particular module of Abaqus. In this case, p will correspond to our part beam, which is inside models, which is inside the model database. And then whatever you do, you can see that he's referring to it. So now, for example, I'm quite sure that this can be commented. So Ctrl Q comments, and then we can run again the script and see if it does what it should. Yeah. You can see that it worked pretty well. Also because if you go in the drawings, and 25 and you saw 400. So you can see that actually we changed the geometry quite significantly and everything quite significantly. So this part can be removed. And then here you create the material. This is the material part. So essentially here you create the material with your young modulus and post-smart ratio. Also this parameter can be inputted. For example, we can put 100,000, 1, 4, 3, and then this can be copied directly here, and the other one here. And then so on. So this will change this material. So then if you want to run another analysis with another young modulus, you have just to change this number and then run the script. And you can even have the submission code, which is this one, activated. So every time you run this, analysis will start immediately. Oh, because okay, I don't want to jump, but so we will arrive to that. So now you can see that now we create the material. Here we are creating the section. So this part will create the section. No thickness is assigned because it's a solid. And then here you essentially assign that section. And this is done here, P section assignment. So this P section assignment, but it doesn't need many of these commands, needs a region, section name, or whatever variable name, and then some values. In this case, for a section assignment, he needs the region. And the region is defined here in P set, where P is this one, so is the part in the model. But then we need the cell, and the cells, is defined here. And this is a classical command that in the future we will deal with more with a proper video, because this one is good when you have smaller model where essentially there is no problem in fetching a part by clicking, because it will always be the same. In this case, because I clicked on the model, he created this mask. So at the moment I'm not sure how we can track back the mask numbers. So in most of the case, the best way to take things is not using this command if the model is more complex, but by using command that, depending on some parameter that you impose, will look for particular geometries and will select only those. This is the best way, the best practice. But now, because the geometry is very simple and we are at the beginning, keeping these is fine. So what this will do, will essentially click on and take the volume of the beam and assign here to create a set. And then with this set, he uses this region here to do the assignment. So to assign the section that we created previously. Then here, we switch to the mesh. All these parts belong to the mesh, and you can see that there is a command for generating the mesh, generate mesh, which is based on this P command, which is always the same. In reality, you can repeat this only once, but it doesn't matter. More times you repeat, more time you will overwrite, so you are sure that you are repeating the correct one. Here you are seeding the part, and this seeds is here, and also this can be a parameter. then you can put here. And the nice thing is that it's very difficult to do mistakes, because he will remember all these variables that we define and we use, so he will suggest you, so it is much faster to script. So now that we did these, we're going to step forward to the end. Also, these are the parameters that can be transformed in parameters, but at the moment we are not going to do this. So these will generate the mesh, and you can see once again we define P. I can show you that this particular command can be commented out. Now you will see that the mesh will become more refined, and you can see that because P was already assigned, so there is no reason for citing many times. Is something that doesn't harm, but if you want to have your code tighter, it's a good idea to start to do so. Honestly, I don't delete them unless I'm at the very end of my work, so I'm sure that the code works perfectly, and then I start to think about the statics. Okay, now this part is all regarding the meshing, and in particular here you can see, yeah, all this part is for creating just the instance and to assign the instance. But this part, not. This part is just me rotating the camera, zooming the camera. So we can remove, and we are sure that nothing will happen. So this will run smoothly anyway. And you can see that it does. Then here we start to have a very important part. So defining phases in order to define sets. In this case, boundary condition set. And here again, defining phases to pick up a specific surface to create a set for a surface. These are all chunks. And then we have the definition of the step with all those options modified. For example, now we can put period 1, maximum number 100, and 1 here, and this can be off because we don't need nonlinear geometry. So you can see that it's very easy to modify these things. These are other commands that are defined with definition of the step 1. And there are values that affect step 1 only. In particular, these are essentially saying to you that load will be used, boundary condition will be used, predefined field will be used, connectors element will be used, but adaptive mesh constraint not. These can be modified by the user, but these are standard. Then here we create the surface. This is another set. Sorry, it's not another set. This is essentially the definition of a region, because then we have to apply load. A load that has a certain entity. For example, P load. And then we can define this prior. And this will essentially apply the pressure on this surface that was defined here. Now you see why I use Node++, because it's very good to surf through the code very rapidly. Then you have the definition of your load. to be saved. And then there is other junk regarding the moving of the view. And of course, we assign the boundary condition to the size set, and you can see this here, because he needed to apply this boundary condition name with these particular conditions to a specific region, this one. For this reason, you have essentially a equal something, then this something is used with the keyword set in order to create the boundary condition set. And then, last but not least, the creation of the entire job. So now, and you can see there are a lot of options that we will discuss later on, but at the moment, this is pretty standard. So now, what I'm going to do, I'm going to run again the script. And you can see that it's done, everything has been done, and the job is here. Now, what I'm going to do, I'm going to shift to the file that I'm going to upload, and you will be able to download. So essentially this is a tidier version of the previous file, and you will see that essentially a lot of options are here commented and are much easier to be read. A good thing to do eventually is opening again, and this I will show you how good is scripting and how easy is scripting in Python. Now, if you look for step since from the beginning, in particular create step, here you can see that I have no means in creating a particular and specific option for my step, because my step is defined here. So what I can do, I can go here and essentially copy these and paste here instead of the other one. So this will allow me to create a step with these properties. This will be very important because it will strengthen my capability of changing things. So I'll show you very rapidly what this code does, and you can see. And then I can submit the job. And hopefully it will run smoothly without issues. Yeah, the job completed. Of course, it's a very simple job. The mesh is a bit insane for the level of complexity of the problem, but you can see that the problem has been solved smoothly. So I hope that you enjoyed this video, and I will continue next week with another video more focused on making loops inside your Python code in order to make more efficient your way of doing analysis. If you have any comment, please leave it down below, and subscribe the channel because a lot of new things will come soon. Thank you for watching, and see you the next time.